have some getting started. Do you hear me all right? Sounds good? All right. So, hi everyone, welcome to reInvent 2024. Today we will be talking about generative AI for millions. We will dive deep into Amazon's Rufus and product review highlights. My name is Burak Gozluklu. I'm a principal machine learning specialist solutions architect in AWS, helping Amazon as a customer. So today I am with RJ. RJ is the principal engineer of Amazon Rufus. He's here. And Juan is the director of engineering for the review highlights. So we will be sharing some information about our learnings and some solutions. By the way, this is a silent session, so unfortunately we won't be able to take questions during the session, but we will be happy to answer your questions at the end of the session. Okay. So we start with generative AI on Amazon.com. We walk through some examples that went to production this year. And then we dive deep into review highlights with Juan, and then we dive into Amazon Rufus, and then we finalize everything with key takeaways. So no matter what we build for Amazon.com, we have two big challenges. The first one is definitely the speed, and the second one is the scale. So by the numbers, if you look at the number of products, we have more than 400 million products right now on Amazon.com, and we are serving more than 200 million customers, prime customers. And we deliver more than 7 billion products every year. We got more than 12 million new orders every day, and for every year we get 1.2 new reviews written by our customers. And most of the purchases actually taken less than 3 minutes, and this number is all done even faster. So the speed and the scale is always the big challenge, and we address the customer's need from that perspective as well. So one of the innovations using generative AI this year was product listing expert. So if you go through an Amazon.com, you will see a product listing. The product has a title, description, all the categories, which is more than 50 categories right now. Is before this technology needs to be mostly created manually by our sellers. So with this technology now, we help our sellers to create a draft or the product listing using generative AI. Sellers can give a URL to the product information. They give some information about their product, and the generative AI tool generates that listing in the best way, such that it applies the best practices, it is complete and correct, so that the seller can quickly iterate over the best practice listing, and then the seller can go from there to put that listing or edit and then deploy the listing. So this is very welcome. Today we have more than 100,000 sellers using this technology, and we are reaching to millions of inferencing with this technology end of this year. The other one is, if you may notice, for some of the items, we have some AI-based recommendations. Recently, I purchased a shoe, and it was a specific brand, and the AI said, hey, you should purchase a one smaller size, given what the others are purchasing and your purchasing experience. So this is, again, using generative AI behind the scenes. Not completely generative AI, but generative AI is part of it to give that recommendation to you for that purchase decision, so that you make the right decision. And recently we have announced AI shopping guides. So AI shopping guides is like a decision tree you can think about in order to, for example, in this case, you would like to buy a monitor, and it walks you through some basic decisions, some step-by-step decisions, so that it filters those product recommendations for you at the end of the session. It uses, again, generative AI in some places. It's not completely generative AI, but generative AI is a strong part of this solution to give our customers the better decision to purchase. So from the seller side, recently we have announced Amelia. Amelia is another conversational assistant, but this is now for our sellers. Our sellers may ask questions about, hey, there's this holiday time is coming, I would like to list a best practice product, how can I do that? Or the question could be, how is my business doing? How is my sales going? Or maybe the seller might have a ticket that the seller opened with Amazon support, and the question may, how is my ticket going, etc. So Amelia answers those questions 24/7 using generative AI and helps sellers to quickly go through those questions. So this is being used by thousands of sellers today. and gets more and more attention. It uses information about our seller universities, and on the back end, it utilizes all the databases to provide the correct answer to our sellers. And Amelia uses Bedrock. The other application, which is not conversational assistant, is coming from ads, Amazon ads. We call this creative ads generation. One of the biggest challenges for our customers, actually sellers and advertisers sponsored products, is to create engaging product images or even videos. In this example, there is a shampoo and the seller would like to create a nice background on a beach. And then you put your prompt there, hey, I want this background, and the generative AI create the combinations and different versions of that background for your products. And then you can click and drag and drop your product to place it again, to find the right placement so that you can use this in your product listing. And recently we have announced the movie version of it. It just generates a quick clip, a short clip, based on your prompt, so that you have a better customer experience for your product. So today we're gonna dive deep into two products, products on Amazon.com. So the first one is Review Highlights, and the second one is Amazon Rufus. How many of you have a chance to use those products? If you can raise hands. Okay, nice. A lot of people, I see. So if you go down on the Amazon.com application on the product, you are going to see there are customer reviews, but also there is a summary of those reviews. And it is not just a summary, but also some aspects are highlighted, such as performance or ease of use and such. And there's a color coding next to that one, which gives the sentiment. If the sentiment is positive, it is green. If it is negative, it's orange. That one we'll talk about deeply today. And the second one is Amazon Rufus. Amazon Rufus is your shopping assistant, conversational assistant, the Amazon expert. So you can ask questions about the product. You can start your search with Amazon Rufus. What I typically use, for example, is if I have a specific question about that product that it is hard to extract, and I ask this, hey, is this product doing this? So you can use Rufus as a companion, shopping companion. So there is a reason why we picked these two projects for you. Review Highlights and Rufus are actually providing a cohesive and a customer experience for you, right? The first one is conversational, the other one is more about like interactive and static information. So these two applications are two edge of the spectrum. Review Highlights is interactive, static, whereas Rufus is conversational, right? For the mode wise, Review Highlights is an offline mode, use of large language models. For example, if you click to a product, you don't need to wait for the endpoint to calculate those review summaries. That review summary was already calculated for you, created for you, and cached for you. So as soon as you click, just like you see the actual reviews, you can see the summary as well, right? So this is an offline processing, an offline application of large language models in production. And the Rufus, on the other hand, is real time, right? You are having this conversation with the chatbot in real time. Inferencing, to different examples, batch processing async, whereas streaming. For scale-wise, Review Highlights needs to operate through billions of reviews. In some product, we have tens of thousands of reviews per product, whereas for the Rufus, it's more about the scale for millions of customers to have this low latency engagement. So we believe that these two examples give you a good breadth of the large language model applications for a static and offline versus a real-time streaming applications. So yeah, that's it. Let me call Juan, who can dive deep into the product Review Highlights. Thank you so much.
Thank you, sir. I appreciate it.
It is really.
Can you not hear me? You can hear me. Okay, good, great. Actually, this is very weird, by the way. Like, the only time I've ever seen technology like this before is like the silent raves. Hopefully this is fun, but I know it's not going to be that fun. Anyway, today I want to talk to you about Review Highlights and a product that my team developed and built. As Brock was talking about, I think what's really interesting and kind of cool about this is the way that we worked backwards from the customer and let the customer and the customer needs dictate the technology that we used and how we built this. It's going to be probably a little bit surprising what we built. In some ways, maybe a little bit more simplistic than you were thinking, or maybe more controlled than when you're thinking about generative AI and some of the issues that come up with generative AI. But on the other hand, we had a very specific customer use case that we're solving for. We built for that use case, and we're really happy with what we've done and how we've done it. And I think there's some really interesting learnings, not the least of which is guardrails, safety, human in the loop, and really cost control and frugality. Really important here and interesting about what we did. So, I've been involved with customer reviews at Amazon in one shape or another for at least the last 7 years. I've done a lot of different things at Amazon, but I've been part of customer reviews for quite a while now. And customer reviews is one of the oldest and most trusted elements of the shopping experience. I wish that we could have a little bit of an interactive thing where I could ask you how old you thought the longest and oldest active review that you can find on .com is today. I can't ask you that, so I'm just going to tell you. It's having its 30th birthday next year. So there's a book called The Hot Zone. If you were to go pull up the reviews on that, you will find a review in there that is 29 years old and still relevant today. So it's a feature that's been around for a very, very long time, but it is super important to our customers. The vast majority of our customers read the reviews. Most of them are reading multiple within a month when they sit down to make their purchases. Our customers consistently tell us in everything that they do that customer reviews and having trustworthy, honest customer reviews is one of the most important things that gives them confidence when making a purchasing decision in the store. So we cannot afford to use the same technology and the same interfaces and the same expectations that we had 30 years ago today. One of the biggest problems that we have with customer reviews is that there's a lot of them. And you would think, that's actually sounds like a pretty good thing. Like it's a lot of customer generated content, it drives trust. But when you have a product that has 10 reviews, great, you might read them all. If it's got 100, it might be a little tricky. If it's got 1,000, 10,000, 100,000, we have some products on the site that between ratings and reviews have more than 1 million pieces of user-generated content submitted just on that thing. And so your ability to read through those and to make sense of them is basically nothing. So what we need to do is provide you ways to, as a customer, to understand the entirety of the wisdom of the crowd, and review highlights is just one mechanism that we've developed to do that. So the way that it's kind of built and the way that you'll see it as a customer is when you're looking at the reviews section, you'll see a section that's the overall summary. This is a LLM generated summarization of all of the reviews within the corpus. But what it's really doing is it's looking at some classic other types of ML models and their outputs in order to generate that summary. So really what we're doing is we're looking at all the reviews that are out there, and we're taking all of the content that's in there, we're applying some semantic understanding and some language models to it to bucket all of that content into different buckets, to then create labels for those buckets, and then to apply sentiment to those buckets. Is it positive? Is it neutral? Is it negative? And then using all of that to build up to the overall summary. But we also believed when we built this that having proof for the customers available so they could click through and read it and not just take the AI word for it, not just take the LLM's word for it, led us to also provide review snippets for each one of these. So the customers can really go in as deep or as shallow as they want to interrogate and understand what the wisdom of the crowd is telling them about this product. So as we sat down and we thought about this, so if you go back to November 2022, and ChatGPT has come out with OpenAI publicly, and it's kind of a trimmer that's felt everywhere. We thought, well, we can use something like this to help us in this quest that we have within customer reviews to help customers make unregretted purchase decisions. That's the way we think about it. It's a little bit wonky, but I want customer reviews to help shopping customers make a purchase decision that they will be happy with, that they won't return. They'll say, yep, I read those reviews, I understand what other people were saying, and I made a decision to buy or not to buy, and I'm very happy with that decision. So we thought about, well, what would have to be true with this new product as we're building it in order for it to be useful for customers and to maintain customer trust? So we said, well, it's got to be accurate. We cannot hallucinate reviews. We can't hallucinate reviewers. We can't hallucinate facts. It has to be accurate and data-driven. Probably means making sure that we have a really good human-in-the-loop process and monitoring. It has to be responsible so that customers can check our work. It's got to be transparent and secure. It's got to be something that is available to customers with basically no latency. They're not waiting. We're not injecting time and friction into the process for our customers. And a little bit more than just summaries, as I talked about. Like, a summary is great, but a summary on its own isn't enough. And so when giving those proof points to the customers. And lastly, and probably not the least important, is the cost effective. And so with 22 different marketplaces in 28 different languages and 6.5 billion different pieces of content submitted by customers over the years, we needed a way to do this in a quick and cost-effective way for our customers. And so that's what led us to kind of the offline batch processing. So, as I alluded to a little bit when we were talking about it a couple slides ago, what we ended up doing is combining multiple different models to be able to provide this output. So we used a lot of traditional NLP, and we used LLMs only when necessary to save costs, to increase accuracy, and to create artifacts, useful artifacts that we could export and use in different places, not necessarily using LLMs. So marrying those two together. And the way that we thought about this was not, hey, there's a new shiny set of tools out there, we should use those tools in whatever way we can possibly find, but we have a customer problem. It's a durable customer problem. How do we solve that problem for our customers? And we weren't wedded to a particular solution, and that's really what led us to thinking about, let's take some of the work we've done over the years with natural language processing and marry it to LLMs to kind of get the best of both worlds. So essentially we take our customer reviews, our raw data, we use a variety of different traditional ML and LLMs. We also leverage the AWS developed chip, ENFA2, and it allows us to come up with content and information that we can cache and provide to the customer, to the client when they want it. It is cached, yes, but it's also fresh because we do update those summaries and those reviews as new reviews come in. So if a new book comes out and it's a very popular book and it's getting a lot of reviews, as those reviews come in, we're constantly looking to see, is there new content? If there's new content, should we rerun these processes? Should we come up with new aspects? If we do come up with those new aspects and there's enough information, we have workflows to trigger creating a new summary. So it's always cached, it's always ready, but it's also always fresh, which was important that we didn't have stale information. What's super important, given that customer reviews is a data element that's used not only with customer reviews on the shopping page, but it's also information and content and data that's vended out across Amazon to a ton of different systems, from search to advertising and everywhere in between. It was really important that we built this in a way that we felt like our data could be canonical and could be vended, and so that it's always cached, always fresh, and always available to all of our clients in the right form at the same time. So we partnered with Brock and some of our other friends at AWS to add some functionality that wasn't there before. So we're now able to do batch transform with SageMaker. So if any of you are using SageMaker, you now have this capability available to you in the tool, which we're super excited about. And that allows for offline batch processing of reviews. And so if you were to use SageMaker for any of your model building needs, you now also have this batch transform capability available to you. We use the ENF2 chipsets, which hopefully at this point but I'll reiterate the point, perform at a 40% better price point than competition. And because we were doing this work up front, we were able to use smaller LLMs to actually do some of the work once we had all of the aspect data and other information processed, so that we could run on smaller LLMs and get the same quality results with limited hallucinations and proper guardrails for our customers. As we learned along the way, and as I'm sure you know, if you've got any interest in LLMs or AI at all, is that human information and the quality of the information that the humans provide us is crucial. and is really important in the feedback cycle. So along with everything else that we built, we also have a team of human annotators that allow us to cover all of the languages that Amazon covers with our cross-lingual models to provide timely feedback and consistency so that we're constantly auditing and updating and improving the output, whether that's for information density or fluency. We've set our guardrails across the model and the way that we want it to perform and the expectations that our customers have and what we're showing them. And we're constantly reiterating and revising with our human annotators and monitoring for better feedback. We also pay attention to the information that our customers give us directly through escalations, through the data they provide us, through their shopping behaviors and their consumption patterns. But having humans that work with us directly to provide the annotation has been a critical function of ongoing success. So we launched this initially in its very smallest form May a year ago. And then even through this entire last year, we've launched at least 2 to 3 to 4 different experiments every month this entire year, driving a ton of additional customer value as we've iterated, improved it on almost every aspect of the feature. So I think that's another important piece, is that we built it, we launched it, but we weren't done. We measured our success, but we also measured our failures and figured out, like, where are we not hitting things right? Where does the language feel stilted? Where are the aspects not interesting to people? Where are we not helping people make a good shopping decision? And constantly reiterating and having a roadmap to refine and polish the product for our customers. So at the end of the day, we've built this one feature. It's an interesting counterpoint to what RJ is about to speak to you about, which is a much more open-ended conversational LLM application. But in this case, we used LLMs beyond conversational assistance at a massive scale, but a very constrained use case, because we were working backwards from the customer experience and expectations to marry together traditional machine learning along with LLMs to save costs and increase efficiency. And I mean, we have this proof point. I probably can't share the exact number with you, but I will tell you, if I could, you would be staggered by how inexpensive this is. I think LLMs definitely have a reputation for being extremely greedy, both consumptive in energy and compute time, but you can have an AI solution that is extremely cost effective and efficient, and this project kind of proves it the way that we built it. Additionally, the artifacts that we created along the way are vendable and usable through a ton of other different applications on the website, and so we've been super happy with the way that customers have responded to this, the response that we've gotten, and we continue to iterate and partner with other teams in Amazon, including teams like Rufus. And right now, actually, I'm going to hand it over to RJ, and he's going to talk to you a little bit about kind of the other side of the coin, which is an open-ended conversational shopping assistant and AI. Thank you for your time.
Thanks, Bowen. I'm Ajay. I'm an engineer with Amazon, and I've been working with Rufus for the last year. And like Vaughn said, he's working on a 30-year-old project, but mine, I'm still yet to celebrate the first anniversary. We just a few months old project which we released, and it's available for all US customers for desktop and mobile. So what is Rufus, right? Rufus is actually your AI-powered shopping assistant, and what we try to do is to help our customers make informed decisions. And to make the informed decision, we answered a wide range of questions which the customers ask. And when we looked at the solution, we understood that we can use some of the latest generative AI technologies to solve it. And when we looked at the technology, right, it's not just the cost, but how we present the customer a good shopping experience rather than waiting for minutes to get the answers. So we have to also innovate on our strategy, on our product, our infrastructure, to give a more interactive approach to the customers to adopt generative AI. So these are the problems when we started Amazon Rufus, we were looking at it. And then, what are the Rufus problems, right? How did we solve it? So to solve it, what we learned is we needed a very customized LLM specialized for shopping, because the data sets are very unique for shopping and we did not want to use any other model to do it. Using our own LLMs enabled us to train and also change parameters which is focused more on inference, which gives us the benefit to reduce the cost. And how did Rufus solve it, right? It's not just the LLM. As you know, your shopping session and everything, you need to have a retrieval sources of your latest data sets and everything, and your journey. For example, when we are trying to recommend you or provide you the assistantship on buying a, when you search for a latest shoe, we look at your shopping history to get you the retrieve source. So we follow something called retrieval augmented generation with lots of evidence sources. And in here, when you see the evidence sources, evidence are the input to the model to make it a better output through the inference. And we also, what we do is when we are actually training and doing the prediction, we also improve the model through reinforcement learning to improve the quality of the responses. And I also provided you the blog where it has given you the more scientific way about how does Rufus do the Gen AI application, and it's available in the bottom. So now the solution, we already know the solution, right? But there were challenges. The challenges is very specific for Amazon, because one of the key things that our customers care is about their user experience. We don't want to affect their user experience by giving a model which they have to wait a lot to get the answers. So one of the challenges that we took is like, we have to focus on our user perceived latency for our LLM models. So the user perceived latency, what we refer is the first token which is rendered in your Amazon app or the desktop. We optimize for the user perceived latency and fine tune our sources and the inference hardware to keep it very low. So that was the first challenge that we understood when we started taking things to production. And the next thing, that as we started scaling, as you know, Amazon have millions of customers, and we are trying to integrate many touch points in Amazon. We suddenly understood our cost is significantly increasing. It's not just the cost, but we are also not getting enough hardware to justify the cost. So the second metric that we try to optimize is cost per million tokens generated, not million tokens input. So this is where, when you're trying to take things to production, you should move your focus to the cost per million tokens generated. Because you can have a larger context length, which is the input to the model, but you can generate one single token as an answer, yes or no. Or you can have a few tokens as the input, but generate a summary, right? So, but when you train the model, you always focus on the quality. But as you take the production, you started to have more emphasis on cost per million tokens generated. And the third pillar that we already know, there is scarcity of this hardware. So we have to make the best use of the hardware which is available to us. We have to work on the efficiency on the hardware, not only the efficiency, but when you provision the capacity, use it at the maximum available throughput. So these were the three pillars, I think, which you can take it away for taking any LLM models to production. And these were the key take challenges. And then I want to start going a step dive into and show you how a Rufus architecture looks like when you do a customer query. As you can see, when a customer types a query like, should I get the trailing shoes? What we do in the RAG architecture, which I explained it before, is we go to different kinds of retrieval sources, like a Wikipedia or your shopping history, or some more detailed information about the product. And we take the input and then we pass it to the LLM inference as the input in addition to the query. And as you can see, the normally traditional LLM inference, you just emit the text, right? And you just show it to the text. But in Amazon way, we need to hydrate your responses so that it is very meaningful for you when you see it. For example, hydration is the way by which you tag something and then we fill in the tag in the application to show the images. For example, in this example, as you can see, we are actually integrating with the Amazon search integration, showing you Salomon's men's extra ultra hiking shoe. The model never says that it should be Amazon search endpoint. The model just tags, can you please use search? And then you can see that images, when do you insert the images? The LLM will just tell you that, can you put an image? Then we have to hydrate your responses to make sure that the customer is seeing not a gibberish text responses, but something that they can click and make it more useful for them. So this is the architecture which we are following. As you can see, it follows the full journey till you get back the responses. And the next thing that what we actually inference infrastructure challenges was the orchestration. Like I mentioned before, we are actually running out of capacity in one AWS region. So normally it is traditionally practiced to have one AWS region for this thing. But because of the capacity constraint, we had to go to multiple AWS regions to give you and then we have to stream the responses back. But because we use the streaming architecture, which I come to lately, we are able to overcome the UPL latency, right? As you can see in this example, when a customer query comes and through the retrieval sources, it comes to the orchestrator, based on the throughput and the capacity of the region, we route the traffic to that particular AWS region. And that's why you need to invest on cross-region capacity. And that is how we actually overcame the region constraints with the capacity. And then, this is another interesting point that I want to convey. We used native ECS service, and then we used NVIDIA's Python backend Triton server as our web server. And then when we launched to production, we used VLLM, which is another one which enables better throughput for the inference service. And when we launched at scale, we used the AWS Neuron SDK and Inf2 hardware. The advantage that we got when we used this architecture is we could actually substitute different kinds of hardwares and then get our experiments running. And then as we get more capacity of a specific hardware, we can just substitute that hardware without too much changes on the upper layer of the stack. So with this architecture, we were able to balance whenever we are getting capacity and whichever instance which is available for that region. And then this is the streaming stack. Now after the streaming was solved, what we understood is the throughput of these instances when you got larger scale is less than 1 TPS per a big box, right? So what happens with that is you cannot fine-tune your load balancer setting. You cannot fine-tune how the responses are getting delayed. Because things are getting delayed, customer is not getting. Till that time, what industry was called static batching. And what we did was actually continuous batching. As you can see in this example, right, when the dynamic matching, when the request comes, the capital of the request 2 also has to wait till the response comes back. But in a continuous batching, when the first response is done, it can end and the next response can get into the queue for being processed. So with this continuous batching, what we were able to get is larger throughput for our already constrained hardware. And the second, we also reduce the UPL latency because now the customer doesn't have to wait in the queue for their request to get to. So with the continuous batching, what we got is actually higher concurrency support. That we are getting more from the hardware. That means there's less queuing in the system where customers becomes more happy because their responses are getting faster. And the third is when we are capacity-based routing mechanism comes into the picture in the load balancer, we were able to better get the load balancer balanced across these nodes. And there also, we also published a blog about how to use Llama 2 using SageMaker is also available with continuous batching. And then other learnings that we had when we were taking Rufus to production. When we came into the picture, normally when we design web application at Amazon scale, you put any instances, it will have a throughput of like thousands or hundreds. It's naturally to get that much high TPS. So all your systems around with architecture is built around it. But when we started building an LLM-based application, your throughput is way low. It is on single digits and can also go less than single digits. So each host can only handle a very limited number of concurrent requests. Because what we make concurrent request is actually the user's query which is coming into the system. And the second thing which you also know when you're trying to launch at scale is because of the capacity constraint, you never get a unified capacity across all the regions or sub-regions or AZs that you have. So you need to overcome this load balancer issue where we know the load is not going to be uniformly shared. And even if a uniformly shared, the throughput at which each machine comes cannot be determined, right? So you have to be balancing on this thing. And how did we to overcome this thing? So the first thing that if you want to take a learning from this session is optimize your LLM for your inference hardware. So we modified our parameters, the size of the model and everything based on the hardware that we are going to run our inference. So we actually fine-tuned our different parameters for the architecture, which is going to be multiple of Inf2s, this thing. And we did not want to compromise on the quality of the model, right? So when we trained our model, they are 32-bit, 16-bit training. But when we went to inference, we looked at whether we can reduce the precision of the model and not lose the quality. What we identified is we can still go to 8-bit quantization, which is reducing the memory footprint and the compute footprint, and still get almost a good result for our customers. And this enabled us to get more hardware to our pool rather than going up beefier and beefier instances. We could increase the model size without asking for a larger model. And then what we did is actually using Neuron SDK, we actually optimized the key profiling pinpoints of our inference hardware. When we look at the latency of an LLM mostly, you can see that you can look at the KV caching and different varieties of optimizing the KV caching. So this is where our investment in Neuron SDK's debugging and profiling capability enabled us to find the hot points and actually work with the team, with the compiler and the Neuron SDK team to actually make it more performant. So we were able to get month over month a significant improvement in our capacity performance, which in turn gives us to lesser capacity required for large scale events. And the large scale events is, for example, a Prime Day or like a Cyber Monday, which is going on right now. You will not get infinite capacity. Because of the investment in this optimization and month over month, 20 to 30% improvement in the throughput, we were actually able to be successfully running the Prime Day without the requirement of an infinite significant capacity removed from our AWS pool. And that's also, we published a blog, which you can get more information how we launched the Prime Day with completely on the Inf2 stack. And then as you go into this thing, the most important thing that we actually want to take away is from you, like, these things are possible on the Inf2 stack. The complete inference of Rufus, which you see in your experience, whether you are in US, UK, anywhere, completely runs on the Inf2 stack. And the journey was actually through the profiling and debugging and matching the performance with the other accelerators. So with the Inf2 being in the market, we are able to diversify our hardware and also scale, because we were able to get the capacity. And also Inf2's cost structure helped us to manage our IMR cost. And IMR is the cost in Amazon we pay for paying the hardware. And what are the results that over the work of this thing that we achieved? As you can see, when you do interact with Rufus, you were able to see we were able to bring down the latency of the first token rendered to you be less than 1 second. And the second, why we find it successful, we were able to deliver the Prime Day to peak traffic for millions of customers with using the LLMs and not having a single issue with that. And we completely launched Rufus on Prime Day on Annapurna chips, and we were able to seamlessly scale and meet our ambitious customer latency requirements. We believe that our customer is always demanding, and it's our job to meet their demands. And what is the conclusions that you would like to take? A good foundation model is a great start, but the cost to serve and take into production is closing the loop with the customer. It's not just the capability that you have. You need to start innovating on how to close the loop with the customers and get into the customer's hand. And the second thing, which you have to focus on the customer experience and re-architect your system if required. Because before we started the LLM project, most of the calls within the Amazon app is synchronized call. There was no streaming support. So we had to go and work with the teams to start a streaming support across the stack, because that's the only way you can meet the customer. So invest in re-architecting your entire system if it is required for you getting the LLM to the production. Third thing, invest in multiple accelerators, because this is very key for you as you continue to grow your footprint and as you continue to grow your reach to the customers, right? Because sometimes if your app is successful, you want to scale. And then at that time, you should not be in a position because of one accelerator. You should invest in multiple accelerators to increase your hardware capability footprint. These are the key takeaways from Rufus. Now I have to pass it to Nan to actually look at the final key takeaways. Thank you.
Thank you, RJ. We have listened to Juan and RJ who share their learnings and solutions. At the end of this session, we would like to harness everything and share you with some learnings and high-level learnings. So probably you kept heard about the customer experience working backwards, right? So at the end of the day, once you observe a challenge, you need to step back and you need to fall back into something. Okay, what are we achieving here? Right, so what is customers looking for here? Like for example, in Juan's case, they decided that, okay, why don't we calculate those summaries and extract those key aspects and then create those summaries on behalf of our customers, because what customers are looking for here, speed and the convenience. For the Rufus, you heard about their optimization for the inferencing, right? So they worried about scale and they optimize their inferencing for the best customer experience. So it's always coming back to customer experience that you need to go back to your design or make necessary changes. So probably one of the most important learnings is production. So our group helps a lot of Amazon groups for their generative AI projects, and we have seen a lot of cases where a proof of concept working very well, but once we try to go to the production with generative AI, we witness some hiccups there. And hey, this worked in my Jupyter Notebook. Hey, this POC worked, but once we go to the production scale, then we start to discover things like scalability, even accuracy and other things. So always keep an eye on the production. This is an extremely important learning for all of those cases, because you may need to go back to the drawing board. Hey, this worked in this POC, but we have to plan for the production. And even for the Rufus case, they had to think about different regions for the scale they are looking for, right? And you heard a lot about Inferentia and Trainium. So these are the Annapurna chipsets that Amazons have. So these chipsets provide you up to 40% cheaper compared to the performance for the competitors. So at the end of the day, what we want to achieve, hey, we have achieved this one, but to increase our ROI, we want to maybe move to Inferentia or Trainium for the model, for the better cost and latency, and even sustainability. And so we have some findings that Trainium and Inferentia have even better sustainability. So this is the end of our presentation. As I said, we cannot take questions, but what I'm going to